I'm Phil Jubb.
This is our mobile robot project.
It's called a Pacer.
Pacer. Okay, tell us what it does.
It listens to your voice commands. And actually, if I'm too loud, it'll go right now.
So we have a microphone right in the
We've
middle.
got a microphone there. We've tweaked it so you don't need to have cones or foam or anything like that. It pretty much just pays attention to what you have to do. We use the microphone. We've got two shaft encoders on the wheels and the inside. We've also got the motors stop are actually the gears run two wheels. The shaft encoders are only on the on two wheels total out of the four wheels. There's some pivot wheels at the front which kind of make it go kind of funny. So that's why we have to use the shaft encoders to get it to go more straight. We have all the commands here. I would state if it's going forward, what certain numbers of claps. It counts the number of claps and it responds based on what the user says.
And it also
bumpers.
depends on what state it was already in.
That's right. So it's got bumpers in the front and the back. We use Subsumption to implement it. We also have a poll. It's a polling system. It's not interrupt driven. The microphone's not run by interrupts. The bumpers aren't done by interrupts. It's all polling. Because we use Subsumption, microphone will assume any normal movement. If it's just going straight and I clap, it's going to respond to whatever the clap is. If the bumpers go, it subsumes everything else. If I tell it to go straight and the bumper gets set off, then the bumper will react and mine will get preempted. So that's basically what it does. You can look at that if you like.
Go ahead. Let's start it.
Okay.
Okay, so if you want to tell us which way you want it to go, I can make it go that way.
Oh, really? Go left.
How left do you want it to go?
Oh,
Stop
you
it.
have to keep changing.
Yeah.
That's a driving
You
left.
decide when.
There's a driving left like this. That's a driving left.
Go straight.
Well, one clap is considered straight. It's also stop. So
When
straight.
it's moving. Well,
If it's moving, stop. So here's an example of a turn left. So first I want it to go straight. Now it's going to turn left. If I want it to pivot left, it's the same left command, but because it's moving,
Already left.
it goes pivot left. So here's the same example of going right. Make it go forward first. Turn right, and then make a pivot right. Pivot right.
You could almost use a voice command.
Yeah,
could,
we
we
do.
do.
We do at home. We just yell at it to go, and when it hears a noise, stop that.
Go right.
It's more low.
Now go right.
Now go right.
Go
Go
right.
right. Now go right.
Go right.
You have to
Yeah.
kind of say it loud enough.
It,
Go right now.
it likes.
Right left. Stop.
How do you make it go right?
You clap three times.
3 times.
Ah.
And then
Sometimes
to stop it, clap once. And then to start going forward.
and backwards is 4 times. Now backwards we had a lot of trouble with. It doesn't go quite straight backwards.
Yeah.
We use the shaft encoders again,
Yeah,
but for some reason it goes straighter going forward. So
Okay, control it so that you go all the way around the block. The battery
It
doesn't
sounds like
seem to
it-
have enough.
it sounds like it's.
The battery is running down. It's very good. Becomes the handpad very, very efficient.
Yeah. What we did
Let it
was.
bump into the wall.
Yeah.
And then tell it to go forward.
Now we had some trouble with the.
Ah, it does.
It does its own when it bumps. It escapes itself. The same with.
Go back.
Backwards doesn't go straight. So it does the same kind of thing. What was I going to say?
Also, if it hits from the side here, it'll probably just get
Yeah,
stuck.
we didn't have much time to put the thing on.
Yeah.
Otherwise, we would the bumper, it only works if it hits directly like that on, not on the side, so that kind of blows it. And if it's too close to the wall like that, turning becomes a problem because it's too long.
Yeah.
But that's
you don't
just-
have you don't have a wire in the bumper.
Yeah, that's because this is so big. Without the car part on it, it turns fine because the wheels are so close to the edge of the robot.
So something I didn't pay attention to is that you do actually wire a little conditioning circuit for the microphone, right?
Right.
Yeah, this is the BLT11 board.
Mhm.
So I see.
And what we did with the microphone, you have a certain amount of time to hit a clap. We have all of our processes and they cycle through. There's a bumper process, a microphone process, the motor process, and there's an arbitrator who decides who gets priority. It can influence the subsumption. What happens is with the microphone, if it hears a clap, it resets a clock so you have more time to clap again. When that time runs out, you go out, you send your request to the motor, right? So you have a minimum amount of time, if you hear no claps, up to a maximum amount of time for 4 claps. That way you have enough time to do 3 claps. But when you do 1 clap, it responds faster, right? So that's how we did it.
Good. It worked quite well.